Okay, so we're looking here, right? And tell me what you think. Am I right? Am I wrong with this first one? So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I put that. Am I right? Am I wrong? Tina, why are you thinking I'm wrong?
Because 4 of those equals 16, and it is not like 4 times 4.
So you're saying exponents would be multiplication and this is addition?
Yeah.
So what multiplication problem would this equal then? What multiplication problem would this be? Jada? Good. 4 times 10. Okay, I'm trying to bring you back to what do you know how to do versus the exponent stuff. So what would this one be then, this one with the 9s? Keelan? 9 times 5, right? Because I'm repeatedly adding is the same as multiplication. And then this last one with the 10s? Cameron? Yeah, it's going to be 10 times 5. All right, so switching gears then, we're looking at this one here. 5 times 5 times 5 times 5 times 5. Gabe? That's 5 to the 5th power versus 5 times 5. What's the difference in those? 5 to the 5th power versus 5 times 5. Yeah, go ahead.
5 to the 5th power is 5 times itself.
Right, so that's this one. Okay. 5 times 5, what might that look like?
Just 5 times 5.
It could be 5 times 5. Can anybody think of it as a repeated problem? Yeah.
5 plus 5 plus 5 plus 5.
Or it could be 5 plus 5 plus 5 plus 5 plus 5, right? So either way I'm looking at it, they're not the same thing. This one would be 5 to the 2nd power. Can you write this one for me in exponent form? Exponent form. Caleb, what is this one in exponent form?
Would it just be 2 plus 2 plus 2 plus 2?
No.
Nope.
In exponent form, we want to write it as an exponent. Connor?
2 to the 4th power.
Yeah, because I'm multiplying 4 times. Yeah, so the exponents, right, is repeated multiplication. There's 1, 2, 3, 4 2s multiplied together. 8 to the 3rd power as repeated multiplication or expanded form, Dakaya. 8 times 8 times 8. Right? And we could then multiply it out. So then you'd say, okay, that's 64. And then that, 64 times 8. Adam, you remember? 512, yeah. So I could do that, right? 10 to the 6 we know would be 10 times 10 times 10 times 10. 1, 2, 3, 4, 5. 6 of them. Now here's where we're stepping up. We're graduating into 6th grade stuff. G to the 3rd power. What would that be, Chris?
G times G times G.
G times G times G. Repeatedly multiplying G together. We don't know what the value of it is at this moment, but we know that G to the 3rd power would be the same thing as G times G times G. What about if I said Z to the, 5th power? What would that look like? Z to the 5th power. Jada?
Z times Z times Z times Z.
Z times Z times Z times Z times Z. So exponents are repeatedly multiplying the base. Very good. Now I want to look at this one, okay? The difference between 3g, which means 3 times g, and g to the third power. So we know g to the third power, Connor, you said it was what? G times g times g, but this 3 times g or 3g, they mean the same thing. What would that one be as a repeated problem? Leo? G plus G plus G plus G. So multiplication is repeated addition. Exponents are repeated multiplication. All right, let's go to the next page. Now, I'm not going to ask you to work this thing all the way out, but what do we think this would be in expanded form? Melissa? Three and 8/10 times 3 and 8/10 times 3 and 8/10 times 3 and 8/10. Yeah, very good. And then, if I wanted to solve it, I would multiply these two together and then these two together. So I'll do it on the calculator just to save us a little bit of time. 3.8 times 3.8 is 14 and 44 hundredths times, bring down this multiplication sign, 14 and 44 hundredths would give me 208.5136. So if I actually worked it out, you'd work it out the same. I'm not asking you to work it out, but I'm saying you would work it out the exact same way you do the other ones. Can we write this one as an exponent? It's number 7 here. Can we write it as an exponent? Casey, what do you think it would be if we put it in exponent form? 2 and 1/10 to the second power. Thumbs up if you agree with that answer. And then to the second power, what's the fancy math term? Fancy math term. Adam? It is an exponent, you're right, but when it's to the second power, there's a special name. Chris?
Cube.
You're close. You're close. Rachel? Squared. Squares are two-dimensional. They have a length and a width. So that's another name for that is squared. This number 8, Nina, could you help me out with that in exponent form? 75 hundredths to the third power. And Chris, what's it called when it's to the third power? Cubed. Very good. So to the second power, another name for it is squared. To the third power is cubed, because cubes are three-dimensional. And again, I could work it out, multiply these together, and whatever I get, I multiply that. Now, a lot of people, like when they see decimals and fractions, they get freaked out. I personally think that the fractions are actually pretty simple to do. So let's first write this as an exponent. What would it be as an exponent? Tyler, could you help me with that? 1/2 to the third power. And typically when you have a fraction, you're going to put it in parentheses to the third power, saying like that's this whole thing is to the third power. Where if I did it like this, it might look like I'm only talking about the 1. So that's why we want it like this. Connor, you know how to multiply out the fractions?
I know how to multiply fractions, but I wanted to ask, you know how there's like squared and then cubed?
Mm-hmm.
Is there for like 4? Is there one for like 4?
Typically, they just say to the fourth power after 3. So multiplying fractions, you can help me with that part?
You just multiply across.
Straight across. 1 times 1 is 1 times 1.
Is 1
And then 2 times 2 is
4
times 2.
8.
8. Very good. So this is going to equal 1/8. Somebody in my last class said, Mr. Seville, the answer got smaller. 1/8 is less than 1/2. Why is that? Jada?
Because like when you multiply fraction with a 1 over, it's getting smaller.
It's good. Why is it getting smaller? You're right.
It's because like you can't change the number on top, so like
Okay, James.
Because 1 multiplied by itself is still equal to 1, but you still have to multiply the bottom 2 times 2.
Okay.
2 times 2 is 4, and 1 you get 8.
You
After you go down, you get the top.
You're right, but even if the top was, if I had 2/3, it would still be getting smaller. Connor?
I like it's kind of like because 1/2 is below 1 whole. I kind of like to think of it also like negatives, and then you add a negative to a negative. Although it's multiplying, it's like it's so negative, and it's gonna get a larger, it's gonna get a larger negative. I kind of like to think that it's below 1, so.
You're doing good. Yeah, so, I mean, you said, right, when you multiply by a number that's less than 1, it's going to go down. Yeah. 2/3 squared. Caleb, could you help me out with that? 2/3 squared, what would that be in expanded form?
Wait, say the question again?
2/3 squared, what would it be in expanded form?
What do you mean by 2/3?
That, I mean, to the second power? This.
2/3 times 2/3.
Yeah, because its exponents are repeatedly multiplying the same thing. And then for the fraction, I just multiply straight across. 2 times 2 would give me 4. 3 times 3 will give me 9. Works out the same way. Sir, questions from anybody?